Happy day. This is Gavoury from the Department of Computer Science and Information Technology. We are going to see today binary tree traversal. Before moving on to the topic, we need to know about tree data structure. Trees are structures which represents the hierarchical relationship. Now, tree consists of a set of nodes and edges. Nodes are nothing but the objects. Edges are nothing, the relationship between the objects. So, let us see the definition of a tree data structure. Tree consists of a finite set of nodes. There is a specially designated node called the root, and the remaining nodes are partitioned into n greater than or equal to 0 disjoint sets T1 to Tn. This T1 to Tn are called the subtrees of the root. So, in this diagram you can see 1 is the root node, 2 and 3 are the subtrees of 1, and a node may consist of, it need not have a child. So, they are called the leaf node. So, after seeing the tree data structure, we have a special type of tree which is called the binary tree. When we say binary tree, the word binary means 2. So, here each node can consist of at most 2 children. So, which means a node can contain 1 child, 2 children or no child. The definition of a binary tree. A binary tree again consists of a finite set of nodes which is either empty or consists of a root and 2 disjoint binary trees. They are called the left subtree and the right subtree. We will see few applications of a binary tree. When we talk about in business, the organizational chart can be represented as a binary tree. With respect to computers, we can see expression trees. This is one example. In an evaluation of expression, in the compiler design, what will happen is the expressions are converted into an expression tree. So, we will move on to our exact topic, binary tree traversal. Traversal means process of visiting. Binary tree traversal means process of visiting the nodes of a binary tree. So, we have here 6 combinations. The 6 combinations are left, data, right, left, right, data, data, left, right, right, data, left, right, left, data and right, data, left. So, why we will come out to 3 combinations because the convention is left has to be visited before right. So, we will be having only 3 traversal techniques, namely the in order, pre-order and the post order. So, when we talk about in order, it is nothing but left, data, right. So, if it is going to be post order, left, right, then data. So, if it is going to be pre-order, data, left, right. So, here when you see these 3 combinations, left will be visited before right. Binary tree traversal, there are means, 2 means you can do it, either using recursive algorithm or using non-recursive algorithm. We need to know what is meant by recursion. Recursion is nothing but a procedure or a function which calls itself. In today's session, we are going to discuss only about recursive method of traversing a binary tree. So, we will be seeing all the 3 recursive methods, namely the in order, pre-order and the post order. So, when we talk about the traversing a binary tree, so the 3 tree traversals are in order tree traversal, post order tree traversal and the pre-order tree traversal. So, what we will be doing in our in order tree traversal? Recursively, we will visit the left subtree, then we will visit the node and then recursively we will visit the right subtree. In the post order tree traversal, we will recursively visit the left subtree, recursively visit the right subtree, then visit the data. Same way, in pre-order tree traversal, we will visit the data, then recursively visit the left subtree and then recursively visit the right subtree. We will see in order tree traversal. So, recursive procedure. So, procedure in order of t. If t not equal to null, then call in order of L child of T, print data of T, call in order of R child of C. With that the procedure ends. So, here in order tree traversal, we will be visiting the left subtree, then the data, then the right subtree. So, in this example, always T will point to the root of the tree. So, it will point to A. Now, at A has got the left child. So, now it will move on to B. B again has got the left child. So, it will move to D. Now, D doesn't have a left child. So, data D will be visited. Then, it will move on to the right child. Since the right child of D is empty, again it will come to D, where it will now the left of B is visited. Now, the data B will be visited. Now, B doesn't have a right child. So, now it will move on to A. So, now left of A is visited. Then at A, it has got the data. Now, A will be visited. It has the right child. It will go to C. Now, at C, C doesn't have a left child. So, it will visit C. Now, C doesn't have a right child. So, with that, the procedure ends. The order in which the nodes visited will be D, B, A, C. We will see an example now. Look at the tree, binary tree. So, in order of A, it will start at A. Now, it will move on to in order of B, right? Then, it will have to, after in order of B, it has to go to, so in order of B, then it will move to in order of D. Now, at in order of D, it doesn't have a left child. So, data D will be printed. Then again it will go to in order of right child, again it is null. Now, D is over. Now, it will again go back. So, now it will print B. For at B, P doesn't have a right child. So, in order of null. Now, the left of A is over. So, print A. Now, it will move on to in order of C. Now, at C, C doesn't have a left child. So, in order of null. Now, data C will be printed. So, it doesn't have a right child. So, in order of null. So, at this point, the procedure ends. So, the order in which the nodes visited will be D, B, A and C. Next, we will move on to post-order tree traversal. So, in post-order tree traversal, again this is a recursive procedure, only the order of statements will be changed. So, now when you see the procedure here, if T is not equal to null, then call post order of L child of T. So, you will visit the left child, you will visit the right child and then you will print the data. So, here it will start again, it will start with the root node A. It will now first it will visit the A as a left child. So, it will move to B. Now, again B has a left child. It will move to D. Now, at D it doesn't have a left child. So, the data D will be visited. It doesn't have a right child. So, it will move on to the previous step where it has branched. So, it will go to B. So, the left is over. It doesn't have a right. So, B data will be visited. Now, the left of A is over. Now, it will move on to the right child. So, in the right subtree, you have the C. So, now C doesn't have a left child nor a right child. So, the data C will be visited. Now, the left of A is over, right subtree of A is over. Now, data A will be visited. So, the order in which the nodes visited will be D, B, C and A. We will see an example now. So, post order of A, it will go to post order of B, post order of C, print A. Now, at post order of B, it will go to post order of D. Now, D, post order of null, then print data. So, D will be printed. After that, it goes to B. So, in B, post order of null, so the data B will be printed. Now, after A, the left is over, now it has to visit the right. So, post order of C. So, for C, it doesn't have a left child. It is null, post order of null. Now, then you will have the post order of C has to be printed because it doesn't have a right child also. So, print C will happen, then now left is over, right is over. So, the data A has to be printed. So, the order in which the nodes will be visited will be DBCA. Next, we will move on to the pre-order tree traversal. In pre-order tree traversal, we will be visiting the data first, then the left subtree, then the right subtree. So, here if t not equal to null, then print data of t, call pre-order of L child of t, call pre-order of R child of t. With that, the procedure ends. So, here A is the root. Now, the data A will be visited. It has got the left subtree. Now, B, it will go to B. Now, the data B will be visited. Then, it has got the left subtree, so it will go to D. So, D will be first, data will be visited. D doesn't have a left child nor a right child. So, now it will move to B. Again, B doesn't have a right child. So, now again the left of A is visited. It will go to the right of A already visited. So, it will go to the right of A, which is nothing but C. C doesn't have a left child nor a right child. So, already the data is C is visited. So, the order in which the nodes will be visited are A, B, D and C. We will see an example now. When you look into the diagram A, so A is the root. So, first we will visit A. Then, so print A. Pre-order of B, then pre-order of C. So, at pre-order of B, it will print B, then pre-order of D, and now D will have print D will happen, then D doesn't have a left child nor a right child. So, what will happen is, again it will go to B. In B, it doesn't have a right child, so pre-order of null. Now, left of A is over. Now, it will go to pre-order of C. Now, at pre-order of C, print C will happen. C doesn't have a left child nor a right child. So, with that, the procedure ends. So, the order in which the nodes will be visited will be A, B, D and C. So, we can summarize. So, using binary tree traversal, we can visit the tree in three ways. One is in order, pre-order and post order. Thank you.